Well, at the outset, I apologize first of all, as the video got cut. I have to do it again now. So, yeah, uh, let me just recap. What is a unit and how it is defined? What is the importance of a unit? All these things we have already discussed in the previous video lecture. And basically, I wanted to cover it. I wanted to cover it up in the same lecture, but unfortunately, due to some technical glitches, the video got cut. So we'll just continue from where we left in the previous lecture. So as we have already defined what is a unit and what are some examples we discussed. So units are basically classified into fundamental unit and derived units. So I've just written the definition over here of fundamental units. So fundamental units are the units of fundamental quantities. Now what are fundamental quantities? We have already seen, but I'll just recap once more. So fundamental quantities are basically the quantities which are not dependent upon any other quantity. The quantities which are not dependent upon any other quantity for their measurement, or in other words, you can say which are independent for the in their measurement. Those are what are called as fundamental quantities. And the units of these fundamental quantities, or the units in which these are expressed, these are what are called as fundamental units. For example, length. Now length is a fundamental quantity, as we all know. You just require a scale to measure the length. You don't say, and that is why it is called as a fundamental quantity, isn't it? It's not dependent for its measurement on any other quantity. So the units of length like millimeter, centimeter, meter, kilometer, these are the units of length, which is a fundamental quantity. So these units of length are what are called as fundamental units. Okay. Someone may say that you may even write micrometers, nanometers, picometers. Yes, that's them. These are just micro, pico, nano, milli, kilo. These are multiplicative factors. After all, the unit is meter, centimeter, like, isn't it? So these all millimeters, centimeters, meters, kilometers, these are all the units of length. And since length is a fundamental quantity, these are all fundamental units. Another fundamental quantity that comes to mind is mass. And the units of mass are what are called as fundamental units, isn't it? So what are the different units in which mass is expressed? As we all know, you may say milligrams, or gram, kilogram. Yes, these are all the units of mass, isn't it? So these all are the units of fundamental quantity mass, and hence these are what are called as fundamental units. The third fundamental quantity that comes to mind is time. Now what are the different units in which time is measured? Yeah, so time is measured in what? Milliseconds, seconds, minutes, hour, isn't it? So these are all the units of time, and hence these are called as fundamental units. So basically length, mass, time, I'm repeating, length, mass, time, these are the fundamental quantities, and all these units of these fundamental quantities are what are called as fundamental units. Yeah, you may say temperature, another physical quantity, and another fundamental quantity. Yeah, so the units of fundamental temperature, degree Celsius, Kelvin, degree Fahrenheit. Yeah, so these are all the units of temperature. So these are all coming under the category of fundamental units. Okay, so basically units of all the, now you may say there are three other. Yeah, so yeah, you can say that electric current and amount of substance, luminous intensity. Yes, that is true. So you may say luminous intensity, that is another fundamental quantity, and the unit is candela, right? Then the sixth fundamental quantity is amount of substance. Amount of substance, the unit is mole. And last, electric current. Electric current, the unit is ampere. So basically you have all these fundamental quantities: mass measured in milligrams, grams, kilograms; time measured in milliseconds, seconds, minutes, hours; temperature measured in degree centigrade, Kelvin, degree Fahrenheit; luminous intensity measured in candela; amount of substance measured in mole; and electric current measured in ampere. So these all: length, mass, time, temperature, luminous intensity, and amount of substance in electric current. These are all the fundamental quantities, and whatever are written in the bracket, these are the units of these respective quantities. So these are all what are called as fundamental units. So basically the units of fundamental quantities are what are called as fundamental units. It's as simple as this. I hope it is clear now. Yeah. Now that we have discussed what is fundamental quantity, fundamental units rather, let us go for the second type. Yeah. Which is called as a derived quantity. Derived unit rather. Yeah. So what is the fundamental unit that we have discussed? The units of fundamental quantities are fundamental units. And what are derived units? These are the units of derived quantities. These are the units of derived quantities. So the units in which fundamental quantities are expressed, those are fundamental units. The units in which derived quantities are expressed, those are derived units. It's as simple as this. Now I'll just in a similar fashion say in the previous case I had written all these fundamental units, fundamental quantities rather, and in the bracket I had written the respective units. So the same, in the same fashion I'll write here as well. So derived units. Now what are the derived quantities? You may take, there are n number of derived quantities. You can obtain n number of derived quantities from the fundamental quantities. So basically what are derived quantities? The quantities which are dependent upon the fundamental quantities, those are what are called as derived quantities. ज्या quantities fundamental quantities वर अवलंबून आहे, त्यांच्या मेजरमेंटसाठी fundamental quantities वर अवलंबून आहे, त्या म्हणजे derived quantities. Now first one I may write as area C. Okay. Now area, see, I'm generalizing it. Now say whether you take area of a rectangle or area of a square, area of a circle, units are the same. Yeah, I may just okay, I'll just explain you a bit here. Area of a circle, suppose, if I write, is what? Pi r square, as you know, isn't it? Pi is a constant, as you know. R is the radius. Now what are the units? I'll write them in bracket. So if the radius is measured in millimeters, this is a constant, of course. Pi is a constant, so it has no unit. So now radius is a length. You may measure it in millimeters, centimeters, meters, whatever. Suppose if this radius is measured in millimeters, this will be millimeter square. Okay. If it is measured in centimeters, the unit of area will be centimeter square. If it is measured in meters, this will be meter square. All right. So yeah. So radius may be measured in millimeters. If it is measured in millimeters, this will be millimeter square, because you are writing r square here, isn't it? If the radius is in centimeters, this will be centimeter square, and if this is in meters, this will be meter square. Okay. Now secondly, suppose if I may take volume. Okay. Now volume, generally suppose if I write volume of a cube, say, what is the equation? See, don't get confused with this. Simply because I'm writing area of circle, See, even if it is area of a rectangle, suppose it would have been length into breadth. So breadth is also kind of a length. So length into breadth, that means meter into meter would have been meter square, millimeter into millimeter, millimeter square, centimeter into centimeter would have been centimeter square. So whatever geometrical figure you may take, the units of that quantity is not going to units of the quantity are not going to change. So just for making you understand how that meter square, millimeter square comes, I have taken the example here. That's it. But whatever geometrical object you may take, these units are going to remain the same. Now here I am taking a cube. Not necessary. You may take something else. You may take say a cylinder. You may take a sphere. Units are going to remain the same. Yeah. So what are going to be the units here? So as we all know, in case of a cube, length, breadth and height are all same. So L into L into L, that will be L cube. Right? So if length is in millimeters, this will be millimeter cube. If length is in centimeter, this will be centimeter cube. If this is in meter, this will be meter cube. Right? So these are all the units of volume. I'm repeating. Here I have taken the object as cube. It doesn't mean that if you take a cylinder here, if you take a sphere, these will change. It doesn't mean that. Okay. So whatever geometrical figure you may take, the units of that quantity, which is volume here, are going to remain the same. If you take volume of sphere, volume of cylinder, these are going to remain the same. Just for the sake of your understanding, I have taken this example here. Right? Okay. Now, let us proceed now. We may take a third example, say, suppose if I say velocity. As you know, velocity is nothing but displacement upon time. It is displacement upon time, isn't it? Now say, displacement is what? Basically, displacement is length, isn't it? Displacement is a length. Suppose you have a vehicle over here at point A and it reaches point B, say, in some amount of time, okay, in a definite time. Say if the vehicle was initially at A and it reaches point B, it covers a distance of say 2 kilometers. Okay, naturally it will take, see, it has moved from one point to another. In other words, we say that it has got displaced. मराठीत आपण विस्थापन जे म्हणतो, एका पॉइंटवरून दुसऱ्या पॉइंटवर ते ऑब्जेक्ट गेलं की आपण ते विस्थापित झालं असं आपण म्हणतो. वी से दॅट इट हॅज गॉट डिस्प्लेस्ड. सो द सेम ऑब्जेक्ट विच वॉज ॲट पॉइंट ए, नाव इट हॅज reached point B, so it has covered a distance of 2 kilometers. In other words, we'll say that 2 kilometers is the displacement of the object. Now you may measure this displacement in, say, I'll just take it here, kilometers. Suppose whatever, now say it covers a distance of 2 kilometers in, say, what, maybe I'll just take a little greater distance, greater displacement here, say 22 kilometers. If it covers in, say, 1 hour, as an example, the total distance is 22 kilometers and it is covered in, say, 1 hour. If the vehicle goes from A to B in 1 hour, and during this journey from A to B, 22 kilometers is the total displacement of that particular vehicle. So how will you find the unit of this velocity? Naturally, it has gone from one point to another point. That means it must have acquired some velocity, without which it cannot move to the other point, right? So displacement here, displacement means what? It is basically what? The distance between points A and B, that is 22 kilometers. It is in kilometers, divided by means per, and time is measured here in hour. Okay, so here the unit is kilometers per hour. The length is measured in kilometers, divided by means per, slash, and time is measured in hours. So unit is kilometers per hour. Suppose if this distance was measured in meters, what it would have looked like? If this distance was in meters, meter displacement is in meter, divided by means per, and time is in say seconds. So we would have written it as meters per second. Suppose this distance or this displacement, the length was in centimeters divided by means per. Suppose if it was measured in millimeters and time was in seconds, it would have been millimeters per second. So basically, these are the various units in which this velocity of the object is measured. See, naturally, see, the vehicle obviously had some velocity, and due to which it has gone from A to B. It is not stationary; it is moving, and because it is moving, it has gone from point A to point B. So naturally, any moving object will have a certain velocity, and it is moving. That is the reason why it has reached point B. Otherwise, it cannot. Okay, suppose you're going from say whatever, maybe I'll say from Malvan to Kudasi. The distance is 22 kilometers. Initially, the vehicle was at, suppose this is Malvan. The vehicle was in Malvan, and this is after say 1 hour, it covered this distance of 22 kilometers and reached Kudar. So it has covered this distance of 22 kilometers. 22 is as an example I'm taking just for your understanding. Yeah. So this distance is covered in 1 hour. Okay. So basically, this is the displacement of that vehicle. This is the time taken by the vehicle to go from one point to another point. What I mean to say is the vehicle is any moving object will have a certain velocity, and that is what the unit of which we are finding here. Okay. So n number of examples can be given, like suppose if you have momentum, right? So momentum, now momentum is denoted by letter P, small p, and it is nothing but mass into velocity. Okay, so what will be the units here? Say mass is measured in kilograms and velocity is measured in meters per second. Okay, we'll come to that a little later when we are using the mass, unit of mass is kilogram. Why we should take meters per second only? Why not centimeters per second? There are different systems of unit, and all those things we will discuss in detail. But just yeah, we will come to that a little later. So mass is in kilogram, velocity is in meters per second. If mass is measured in grams, because it is multiplication, I am writing a dash here. If it was division, I would have written a slash here. Okay. If mass is in grams, velocity is in centimeters per second. So these are the units of momentum. Okay. Now suppose I may take say work done. You can give n number of examples, like it is force into displacement. Yeah. It is force into displacement that gives you work done. Okay. So what will be the units here? Force. Okay. Before proceeding with this, let me just take the example of force first of all. Anyway, we'll come to that. Let us take what is acceleration rather. Acceleration A is nothing but velocity divided by time. It is basically change in velocity per unit time. Change in velocity per unit time, that's true. So change in velocity, yeah, so whatever it is, final minus initial, whatever. So it is velocity in numerator and time is in denominator here. Yeah. So here velocity is measured in meters per second and time is in seconds. So obviously it will be meters per second into second, it becomes second square. If velocity is in centimeters per second and time is in seconds, what will it look like? Centimeters per second into second, that is second square. Okay, so basically this is the manner in which the units of derived quantities are found out. Okay, so units of derived quantities are derived units, units of fundamental quantities are fundamental units. See, it's not possible to find out the unit of each and every. Uh, it is not possible practically to find out the unit of each and every quantity in this lecture. So, I just I've just explained to you the procedure or the method in which the units are found, the derived units are found, because there are n number of quantities that you can think of. So basically, this is the procedure that is going to be adapted, and we just have to find the units of the derived quantities. Okay, so yeah, you just take an exercise like find the derived units, of course, of the following quantities. I'm not writing in full now. Yeah, so like you have density, you know what is mass, you know the units of volume. So obviously, see, basically to find out the units, you should know the formula first of all. So you should be thorough with the formula, then only you can find out the derived units. Okay, so be clear with that. Yeah, density, you may find power, electric power, you may find impulse, you may find the unit of force, work done. I think that should be enough for the day. Yeah, so likewise you can. Yeah, so derived units means, in a nutshell, derived units means the units of derived quantities, or the units in which the derived quantities are expressed. ज्या युनिट्स मध्ये derived quantities express केल्या जातात, those are what are called as derived units. So whatever procedure I have shown here, how the derived units are found, but as you can see here, you should know the formula. Once you know the formula, it's very simple task. So you can easily find the derived units. Okay, so this is it. Yeah, all right. So I hope you have understood what is a fundamental unit and what is a derived unit. Okay. And how what are the derived units of these various quantities, that also I have given you as an exercise. Yeah, yeah. So now after this, so in a nutshell, I'll just recap once more. Fundamental units means the units of fundamental quantities. Derived units means the units of derived quantities. Okay. So what are the fundamental quantities? We have already discussed here. I'm just recapping whatever we have done. The units of fundamental quantities are fundamental units. Likewise, you have 7 fundamental quantities in nature, like length, mass, time, temperature, luminous intensity, amount of substance, and electric current. So the units of these quantities are written in bracket here. Length, millimeter, centimeter, meter, kilometer. So any unit of length, that is a fundamental unit. Any unit of a fundamental quantity can be termed as a fundamental unit. It's as simple as that. I'm just repeating because you should remember this thoroughly. You may say micrometers, millimeters, nanometers, picometers, megameter. Yes. See, this nano, micro, milli, whatever, these are the kilo, these are the multiplicative factors. Basically, the units are these only, millimeter and centimeter. These are the only two fundamental units of length. But these are just written in terms of multiplicative factors. Okay. So likewise, mass is measured in milligrams, grams, kilograms. These are the fundamental units. Time, milliseconds, seconds, minutes, hours. Temperature, degree centigrade, Kelvin, degree Fahrenheit. Luminous intensity is measured in candela. Amount of substance is measured in mole. Electric current is measured in ampere. So then what is a derived unit? Okay. So as I explained, these are the units of derived quantities. Okay. So you have area. Now just for the understanding purpose, I have taken area of circle here. Not necessary, as I've already explained, not necessary it should be a circle. You may take any example. You just try it out at home, like area of rectangle you may take, area of square you may take, area of what parallelepiped you may take, area of rhombus. Equations may change, but the units are going to remain the same. So just be clear about it in your mind. The units of the quantity will remain the same, whatever be the geometrical figure that you are taking. Okay, so area of circle is pi r square. Pi, as you know, 3.14 is a constant, or 22.7. 22 by 7 or 3.14 is a constant. So radius, if you measure it in millimeters, it is square of that, so millimeter square. Radius, if you measure it in centimeters, it will be centimeter square. If you measure it in meters, it will be meter square, right? Now, volume of the cube is length into breadth into height. As we all know, cube has all dimensions same, length, breadth, height, all are equal, so it comes to L cube. So if length is in meter, if it is millimeter, it will be millimeter cube. If it is in centimeter, it will be centimeter cube. If it is in meter, it will be meter cube. Like velocity, displacement by time. So displacement, as I have given the example here, yeah, so you know it. So if displacement is in millimeters, divided by means per, time in seconds. Displacement is in centimeters, time in seconds. Displacement is in meters. Displacement, basically it's a length, right? So if it is in meters, time will be in seconds. Like if this displacement, see, whenever the object goes from one point to another point, we say that it has got displaced. It has moved from one point to, if it has left its original position and gone to the other point, that means it has got displaced. Simple. And whatever the length it has covered, that is what you call it as displacement, right? So if displacement is in kilometers, time is in hours, because it's a larger distance. So we are measuring the time also in a bigger unit, that is r here. Okay, so these are all the units of velocity, which are derived units. So momentum, mass into velocity, mass in kilograms, velocity in meters per second, mass in gram, velocity in centimeters per second. Work, you may work out later on, work done. Acceleration, change in velocity upon time. Change in velocity means what? It's a difference in velocity, final minus initial. So it's a velocity, it's a kind of a velocity. So velocity meters per second, time in seconds. So meters per second into second, second square. Velocity in centimeters per second, time in seconds. So it is centimeter per second. So this is just recapping whatever we have done. So as an exercise, I've given you like find the derived units of these quantities. So you should be thorough with the formula of this, and if you know the formula, it's not at all difficult. You can easily work it out. Okay, right. So in the next lecture, we will discuss what are the different systems of unit. Like you have MKS, CGS system, FPS system, then SI system. What are the different systems of unit, and how to find the units of physical quantities in these different systems. So as it is, we have just started off here, but we'll just explain it in detail. What are different systems and how the units of different quantities can be expressed in terms of these systems. We will discuss it in detail, and then we'll go for what are dimensions, and what are the different rules. All those things we will discuss in the next lecture. Okay, so I hope you have understood whatever we have done today, and if you have any doubt, you can always ask anytime. You're most welcome. So I hope this is very much clear to you, and that's enough for the day. Thank you.